We are working on the Connect 4 project from the YByte Python curriculum available at www.ybyte.in. In the last video, we looked at how we could determine horizontal winners. In this video, we will extend the idea and look at, let's say, vertical winners. Once again, we are checking the entire board. In fact, the philosophy, the thought process is very similar, except that now when we are looking for vertical winners exist, let's say, in columns. So which means that on every column, we are going to look for three possibilities, which are here shown here. Row number 0, 1, 2, 3, row number 1, 2, 3, 4, and row number 2, 3, 4, 5. These are the three possibilities that exist on every column. Since there are 7 columns in all, we are looking at 21 possibilities in all. Once again, obviously, once we find a winner, we are just going to break it there and not search further, which is very logical. And again, the approach would be to extract out a mini list from the board list. In this case, the indexing will make sure that we extract out these items. Quite predictably, the structure of the code to determine, let's say, the vertical winner is in fact quite similar to the case of the horizontal winner. However, there are some important changes which I highlight. First thing first, you notice that I am now looking at rows 0, 1, and 2 only. That's because, as we discussed, on any column, the vertical winner can exist starting from row 0, row 1, or row 2. That's all. Uh, and that's why I say my JJ goes from 0, 1, and 2, and hence it is range 3. On the other hand, on the column side, I could be looking at all the columns, which is why I must have a range until n calls. So which means I'm going to look from 0 until n calls minus 1 column, which is now notice this indexing is different here because now on every column, basically I'm forming a vertical, let's say, section on a column. So I stick on a column KK, but then I look at row JJ, row JJ plus 0, row JJ plus 1, row JJ plus 2. And since JJ goes from 0, 1, 2, I end up searching the entire column. As before, once I form these cells, if I find that I've got a winner, I break. And likewise, once I found, let's say, a winner at a given row, I just break from the outer loop as well. Again, it all comes alive when we see it working. So what I'm going to do is to just copy this entire code over, because remember there's a clear structure similarity amongst these codes. So I just go and create this as, let's say, check, say, vertical winner. Again, remember my JJ will not go all the way to n rows. In fact, I look only till in 0, 1, 2. So that's a range of 3. But my KK will be n calls. And importantly, this indexing would change to say JJ plus CNT and let's say KK, because I'm looking at a specific column and finding the vertical sections of that. So that's the whole idea. This is interesting, like I said, because really we are touching on the indexing on the two-dimensional list here. As before, let's print KK for now. Let's print cells for now so that we can see what is going on. And then, we can create some scenarios to check if we are getting a vertical winner. Now, when I run this code, obviously right now my board is all empty, but we can create a situation where we have a vertical winner. We can do that by just populating, let's say, any one column. So I, for example, go and do board. For example, let's say, the fifth row in, say, column, say maybe 1, and I set it to probably, say, 2. Then I go and do the same thing to, say, the fourth row. Then I go and do the same thing to, say, the third row. And finally, let's say, the second row. So when I look at board now, so if I do, let's say, display board, you notice very clearly I do have a vertical winner, and I would want this to be caught in my code. So when I, let's say, do check, say, vertical winner, look for 2, it tells me that is true. Now, it's interesting to understand how this code actually ran, and we can see that from the value of the cells that we are printing. Remember, we are running the outer loop for the rows and inner loop for the columns. So which means that I basically go and pick up, let's say, starting point of JJ of 0. I look through all the columns, then I go to JJ of 1, I look through all the columns, and so on. And you can see that very, very clearly. In the beginning, I start from, say, row 0. That's why I have 0, 0, 0, 0, 0, 0, 2, 2. That's my, say, second list over here. Then all zeros, obviously there's no winner. I come to 0, 2, 2, 2, because now I go to the next row and I start forming from here. So that's my 0, 2, 2, 2. Again, there's no winner. Finally, at let's say 2222, I do find a winner, and there I stop. Now, of course, for the vertical winner, I could have done column out in the outer loop, row in the inner loop, but I'm just keeping it homogeneous between, say, the horizontal winner and vertical winner, because it's also fine. Now, let's just do a few more tests. Let's say I go and check for horizontal winner. I'm expecting a false, and indeed that is a false because there is no horizontal winner in this. But we can create one more vertical winner just to get an idea. So let's say again I do something artificial. Let's say I go and do on say say 3 and column number say also 3. I make it 1. I go and do let's say row number 2 column 3, row number 1 column 3, and let's say row number 0 column 3. So now when I look at the display board, um, so I have a vertical winner with 1 at this point. Obviously this is artificial because in the real game the game would actually stop, but anyway, just for the sake of testing, so when I do let's say check vertical winner this time down with 1, I expect to see a true quite fast. Again, as expected, I get a true, and also I notice that the code breaks quite fast because remember we are starting in row 0. So I go 0, 0, 0, 0, 0, 0, 2, 2, 0, 0, 0, 0, and finally I have a 1, 1, 1, 1 where I find a winner and I break from the entire code. I hope this is clear. Very logical. Think about it. The important part is this indexing. It takes a while to get used to, but this is where the game is really going on. As always, building activities and applying concepts makes concepts that much more interesting, and that is how we learn Python programming at YByte. Look at our website www.ybyte.in because we have many, many, many such activities that you can learn from. Take care. Thank you so much. Bye bye.